This is November 2015, paper 1, question 8. That's a question all about quadratics and gives you information presented graphically. So it's a section B question, which means you should be writing it on paper separately. In order to facilitate this, I'm going to shrink it down a little bit there. We'll see how we get on with that. Right. So we've got a quadratic function. There. Happy smiley face, which means it's a positive x squared. And they give you the equation here in completed square form, x minus h squared plus k. And you've got some information about the vertex. All the information about the vertex, in fact. And the first question is write down the value of h and k. Write down, the instruction write down means that you don't need to do any calculation. You should be able to just look at the information that's given, and if you understand how to do the question, you can just write down the answer. So, how are we going to write down the value of h and k if using those two pieces of highlighted information that we've got f of x is equal to x minus h squared plus k, and I've got 1, negative 9 is my vertex, or my minimum in this case. Well, what that means, if 1 minus 9 is the vertex, we get a vertex when this, the square part, is 0. And the reason for that is because when you square a number, unless it's 0, when you square a number, your answer is positive. If you square a negative number, the answer is positive. If you square a positive number, the answer is obviously positive. So if you square 0, that's the smallest that any number can be once it's squared. Maybe one way to think about that is to say the minimum value of x squared is 0. And that's true for any number that's been squared. So the minimum value of x minus h squared is also 0. Maybe I'll write that as well. Minimum value of x minus h squared is 0. When do you get that minimum value? Well, you get that if x equals h. And in this case, we know when we get to that minimum value. We get that minimum value when x is 1. So in this case, we get that value when x is 1, which is equal to h. And obviously, if you understand this, you don't have to write all those steps down. The instruction was write down, so you should, if you understand it, be able to write down the answer h equals 1. Similarly, when x is equal to 1, what happens to f of x? Well, if you do, so now we know f of x is equal to x minus 1 squared plus k. And we know that that's true at my vertex 1, negative 9. Well, if we do f of 1, we get 1 minus 1 squared. Oh, that's 0. We knew that. That's the whole reason we chose h in the first place. Plus k. And that's equal to negative 9, because that's our y value that we've got from here. So, since this is 0, since 1 minus 1 squared is 0, that's not really there, and we can write down our k value is equal to minus 9. So, once you're familiar with this, you should be able to just write those two things down without thinking about it. That's h is 1 and k is negative 9. 1 mark each. Part B. find the value of C. So C is this point here. That's our y-intercept. And we now know from part A that f of x is equal to x minus 1 squared minus 9, because we know h is 1 and we knew k was minus 9. I'm going to find the value of c. Well, the value of c is at the point when x is 0. X coordinate is 0. What's the y coordinate? So that's 0 minus 1 squared minus 9. Negative 1 squared is 1, minus 9 is negative 8. So that's our c value. Right, question C, 5 marks. First one that's a little bit longer. Those first two, parts A and B, obviously fairly straightforward. Find the value of P and of Q when you do this. You're going to reflect that graph and then translate it, P and Q, P across, Q up, until you get this new graph that's given here. G of x is equal to negative x minus 3 squared plus 1. Now the negative bit right at the start there, just there, that negative is what does the reflection. So once you've reflected it, you obviously get a new graph. Looks something like that. Crosses the axis at these same points here. And it has a new vertex. The new vertex, well, the x-coordinate hasn't changed. It's only the y-coordinate that's changed from negative 9 to 9. So we've got our vertex there, and I want to rearrange it so that it looks, I want to move it so that it becomes g of x is equal to minus x minus 3 squared plus 1. Well, what's that going to look like? Well, it's going to look like exactly the same graph, but I can write down where its vertex is going to be. G of x has its vertex by the same logic that we employed in part A, has its vertex at 3, because that will make the bracket 0, 1, because that's the only thing that's outside the bracket. When the bracket is 0, all that's left is the one outside. So g of x is some curve with a vertex over here. That's a horrible curve. And here's its vertex, 3, 1. So the question is, how do I translate I want to draw it this way. How do I translate the yellow curve, which is f, well, it's negative f, how do I translate the curve negative f into the blue one, which is g? And the answer hopefully is fairly obvious, because we only really have to look at the vertices. So look at the vertex here, the first one at 1, 9, and then the vertex here, 3, 1. It's been translated across 2 and down 8, which means our vector is given as 2, negative 8, or I can explicitly write P is 2, Q is negative 8. And that's part C done. Part D is find the intersection of the graphs of F and G. So I'm going to just sketch G again. I don't think it's going to be useful, but we know that its vertex is at 3, 1. Graphs intersect when their equations are equal. So this is a case of solving the equation f of x equals g of x. Now usually section B, or often section B questions build, and part A relies on part B relies on part A, and part C relies on part B. But that isn't the case in this example, so each part can actually be tackled independently. So make sure when you're reading these questions, if you do get stuck on part A, that you still read part B and see, do I have enough information to do that? I suppose the only one that really, having said all that, I'm going to, now we've got f of x because we worked that out in part A. We had x minus 1 squared minus 9, and we've got g of x, because that's given to us before we started part C, is negative x minus 3. Oh dear. Now I've run out of space. X minus 3 squared plus 1. See if I can give myself a little bit more space. There we go. Plus 1. So it's just a case of solving this equation. Watch out, because this is an example where there's a clue in the question. Find the x coordinates. That S is telling you should have 2 solutions. My graph is telling me I should have 2 solutions. So it's just a case of expanding out the brackets and solving the equation. Expand out these brackets, you get x squared minus 2x plus 1 minus 9 is equal to minus, I'm going to leave that minus sign outside and deal with it in a second, and just expand out the x minus 3 squared, x squared minus 6 plus 9, that's in brackets, and then the plus 1, so I've managed to run out of space for again, goes there. I probably don't need to refer to the page now, so I'll give myself a bit more space. X squared minus 2x plus 1 minus 9 is equal to minus brackets x squared minus 6x plus 9 close brackets plus 1. I'm going to take that minus sign through. X squared minus 2x, I can collect together plus 1 and minus 9 to make minus 8 is equal to taking this minus sign through the brackets to give me minus x squared plus 6x minus 9 plus 1, and again I can cancel here because I've got minus 8 here and I've got minus 8 there, so they are going to cancel, leaving me with, on the left hand side, x squared minus 2x, on the right hand side minus x squared plus 6x, and now it's fairly straightforward to rearrange it. Add x squared to both sides, take 6x off both sides, so that I've rearranged it to be equal to 0. 2x squared minus 8x equals 0, and I can factorise that out. 2x comes out as a factor, x minus 4 equals 0, which means x is equal to 0 or x is equal to 4. The question, you may remember, asks for the x coordinates. It doesn't ask for the y coordinates, so we don't need to give them. But make sure if it just said coordinates that you would have given them what is y equal to, by just going back to one of the equations at the start and evaluating x. But that is done. End of the question.